On this coordinated robotics cruise, we've got up to 10 vehicles in the water at the same time. That includes the Falcor, the 2 support vessels, plus 7 robots that all could potentially be in the water at the same time. So we essentially have a bit of a rodeo on our hands. And MapTracker acts as mission control. All the vehicles can be displayed on the same map at the same time relative to each other. We can see where each vehicle is planning to go based on loading the missions into MapTracker. We can also see where the vehicles have been by looking at their historical tracks. It also provides a way for us to command and control the vehicles. So we might want to send a vehicle an abort if something's gone wrong. We might want to send a vehicle a waypoint while it's underwater. That can be sent through the acoustic link directly from MapTracker. So it provides an easy way to visually see what's going on, but also visually command the vehicles. The Falcor has been collecting bathymetry every night, and so we get this high-resolution, 3-dimensional bathymetry that we can add as underlays into MapTracker to show us the relief. And then that helps us plan for places to put dives that will be interesting bottom types where we're collecting imagery. And that's helpful for diagnosing communication problems. So for example, if you've got acoustic communication link between the ship and a vehicle, you can look at the line of sight between the vehicle and the ship, and MapTracker can help you look at a profile, and you can see if the profile intersects with the line of sight, you know that bathymetry might be in the way of the communication. The system runs in a web browser and on a server. So what that means is we have one centralized server which assimilates all the data from all the different vehicles, and the interface can then be accessed from any device with a web browser, so whether it's a mobile phone or a tablet or each individual person's computer. And so we've got a couple of instances of MapTracker being displayed up in the bridge. We've also got everybody with their own version of MapTracker tracking just their vehicles of interest. And we've also got a public version of MapTracker, so we're pushing the data off the ship in near real time through the satellite link to a version of MapTracker running in the cloud. That's not only useful for the general public, but it's also useful for the scientists on this cruise when they're recovering their vehicle, because they've got that version of MapTracker open on their mobile phones while they're out on the small boats trying to recover the vehicles. And so it provides multiple uses having that public instance. So there's various hazards of having other vessels that aren't related to our research and that don't necessarily know that we've got AUVs in the water operating in the area, and that poses a hazard to the robots. And so the ones that have AIS transmitters, we can actually track through the MapTracker as well. We've integrated that data stream so we can see where those ships are and what velocity and direction they're heading in, and we can plan around that as well.